Hey guys, we are starting our new chapter, and you have the notes that I gave you. It's just simplifying rational expressions. It's a lot of problems. What I'm going to do is model do two of them for you. You do them with me, okay, in each row, and then you need to do the other two, okay, on your own and bring them to class with you the next time I see ya. Okay? So we're going to do two, and then you're going to do two, but you're going to bring them back, all of these completed. Okay. What we're doing here, guys, is dividing and simplifying rational expressions. Very similar to simplifying a fraction. In fact, when you have the numbers like 16 over 28, you just simplify those the same way you always have. You find a common factor, okay, 16 and 28, both are divisible by 4, right? 16 divided by 4 is 4. 28 divided by 4 is 7. Okay, so you reduce 16 over 28. And then with the x's and y's, what you do is subtract the exponents. If I would write this out longhand, x squared is x times x. I have 16 times x times y over 28 times x times y. Okay, x over x is 1, y over y is 1. The only thing left is an x. Okay, that's how you do it longhand. However, what we notice is however many exponents I have up here, if I subtract the exponents in the denominator, then that's how many exponents I have left. So 2 minus 1 is 1. So I have x to the first left. Y over y is just 1. I don't have any y's left. The final answer for this is 4x over 7. Okay? Number 4 is a little different because I have binomials. I have x minus 5 in parentheses, 5x plus 1 in parentheses. Okay? I can't just cancel the x's out. Okay? Everything has to be connected by multiplication in order to do this canceling. Okay? So the 3 over 15, think about what that reduces to. 3 over 15. Each of them are divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. 3/15 is 1/5. I have an x minus 5 over x minus 5. That's just 1. If I have the exact same thing over the exact same thing, that's just 1. The 5x plus 1, there's nothing I can do with that. There's nothing else to cancel. I can't cancel these 5's, guys, because that's connected by addition. If I want to cancel 5x plus 1, I need to have another 5x plus 1 in the denominator. I would probably just write this as 5x plus 1 over 5. Okay? You don't need the 1 times it. That's irrelevant. 1 times anything is itself. So anyway, 5x plus 1 over 5. Do not cancel these 5's. They cannot cancel. This 5x is connected to the 1 by addition, not multiplication. The only time we can cross cancel or simplify is if all the terms are connected by multiplication. This was 3 times x minus 5 times 5x plus 1. The whole x minus 5 canceled with the whole x minus 5. 3 divided by 15 was 1/5, but there's nothing for the 5x plus 1. Okay, I cannot cancel these 5's. You go back and do the other two, okay, whenever you're ready, okay. Number 5, okay, I would like you to do that. I would like to show you what to do with number 6. Remember that x plus 8 squared is x plus 8 times x plus 8. okay, if you want to write it that way. That might help you see that one of the x plus 8s cancel, but the other doesn't, okay? Do number 6. I'd like you to do number 5 and number 6 on your own. I'm going to show you number 7 because it looks like nothing can cancel. Again, guys, you can't just cancel this way. There's a subtraction. Everything has to be connected by multiplication. And then like here, yes, we could cancel one of the x plus 8s because it's the whole x plus 8. I'm not just canceling the x's and the 8s. I'm canceling that whole factor. Okay, everything has to be connected by multiplication, not subtract. There can't be any, the additions and subtractions can be there, but then you have to cancel the whole factor. So what I'm going to have to do is do what we did last chapter, and I'm going to factor this. I'm looking at 2x minus 4, and I'm going to factor it. So I'm going to take a 2 out. I'm not doing anything to my denominator. This is still 2x minus 4, right? But I wrote it as a product 2 times x minus 2 so that I could see if there's anything that could cancel, and there is. This entire x minus 2 can cancel. My final answer is just 2. Okay? Just 2. Sometimes people, excuse me a minute. Okay, so again, this is just 2. If you would have tried to factor this out and maybe I don't know, you would have gotten the wrong answer, guys. It doesn't work that way. I'll explain it in class. So when I see you, I'm going to explain why this is, that you cannot you cannot cancel unless everything is connected by multiplication. Okay, so try this same idea with number 8. Okay. All right, so going on to this next block of questions, obviously it's a lot of factoring. Okay, so I am going to go and do number 10 here. Number 9 is very similar to the one above, but you have to factor the numerator and the denominator. This one, there's not much I can do with x minus 5. But the denominator is a trinomial. We're still factoring just like last chapter. What multiplies to x squared? X times x. What multiplies to 25? Maybe 1 times 5, maybe 5 times 5. It needs to add to 10. Oh, that will be 5 times 5. Both will have to be negative. Let me FOIL this quick. That's x squared minus 5x minus 5x. Yep, that gives me the minus 10x in the middle, plus 25, because a negative times a negative is positive. This entire x minus 5 cancels. My answer is 1 over x minus 5. Okay? I'm going to just show you how to set this one up. The top, I think you can do. It's a trinomial. You're thinking what multiplies to x squared, what multiplies to 28 and adds to 3. I'll let you fool with that. But this denominator, I wanted to remind you, that's the difference of 2 perfect squares. The square root of 49 is 7. So this is x minus 7, x plus 7. So let's hope one of these is either x minus 7 or x plus 7, so it'll cancel. Okay, think what multiplies to 28, and then get it to combine to positive 3. All right, at least I started that one. All right, so you're going to do the rest of these. Numbers 13, 14, 15, 16. I'm looking to see. I'm going to try number 14. 14's a little different in that, okay, it's a trinomial, but I also could take a 2 out of the top. You really have to look at this and remember your factoring. Okay, let's make this easier. 2 is even, 10 is even, 48 is even. Let's factor a 2 out. This is still 2x squared plus 10x minus 48. 8 and 64, I can take an 8 out. This is still 8x plus 64. It's just simplified. Okay, now I can still go further. This is because right now nothing cancels. Well, I guess I could cancel the 2 8s to 1/4, but we'll do that all at once. Okay, now what I'm going to do is factor this trinomial up top. Okay, the bottom I'm just rewriting. What multiplies to x squared? Obviously x times x. What multiplies to 24 and adds to 5? Oh, I guess 8 times 3. I would try 6 times 4, but that doesn't work. 12 times 2 doesn't work. Positive 8 and negative 3, that would give me x squared plus 8x minus 3x, which gives you the plus 5x in the middle. Okay? So what do we have next here? What can cancel, gang? An entire x plus 8 over x plus 8. And 2 over 8 is what? 1/4, right? 2 goes into 2 once. 2 goes into 8 4 times. So I end up with just an x minus 3 on top. And on the bottom, I have a 4. That's it. X minus 3 over 4 is what this reduces to. Okay, I'll start you with number 16. You're going to take not just a 2 out of the top, but a 2x. Okay, see what you get when you take 2x out. On the bottom, there's nothing I can take out, is there? I'm going to try maybe 3x and 2x, which multiplies to 6x squared. And with 6, maybe try what? 3 times 2. Does that work? That gives me 6x squared plus 9x plus 4x. Yes. 9, 10, 11, 12, 13. That gives me 13x in the middle. Okay, so just see what's left here and see what will cancel. Okay? The next ones, I do want to do number 18 for you. I think you'll notice this is the difference of 2 squares, x squared minus 9, x squared plus 9. This is still x to the 4th plus 9x squared minus 9x squared. That gives you 0, of course, and then minus 81. On the bottom, we have x and x. What multiplies to 27 and adds to 12 would be 9 times 3. Ugh, nothing's canceling. Because this is x squared plus 9. Oh, we have another difference of 2 squares here. X squared minus 9 is x minus 3x plus 3. Sometimes you get an extra difference of 2 squares. I can't do the sum of 2 squares. That doesn't factor. But now I can at least take out my x plus 3. My final answer is x minus 3 times x squared plus 9 all over x plus 9. And that's as far as you can go with that one. Okay, should be okay with 17 and 19. There's not much here. Number 22, just remember, take an x out and make it x squared plus 2x minus 24. Take a 2 out. Make it x squared plus 2x minus 24. They are different. Oh, no, they're the same thing. Oh, wasn't that? I didn't realize I was doing that one for you. Oh, well, they cancel, and you just get x over 2. I didn't mean to go that far with that. Oh, well. You're welcome. Okay, this page, again, we're going to factor a 6 out. We're going to factor, what, a 2x out. See what you get left there. X squared minus 36. Ooh, difference of 2 squares. Factor that and keep going. This isn't done. Factor this. This one will turn into the x squared minus 4, x squared plus 4 thing again on top. And then make sure you factor the x squared minus 4 further. Okay? All right. That's it. Good luck. See you in class.